I am Dr. Smita, Assistant Professor of Bharathasan University. Today I would like to give a brief introduction about DNA computing. So as the name says, computing is carried out using DNA, and there are so many other alternate methods, alternate material. People are doing research to replace the silicon computer. So the reason for which we are trying to replace the silicon computer is the Moore's law, that it has been predicted that transistor would get to a point where they could shrink no further. That is by 2021, there will be a saturation. So people are finding an alternate material for computation. So one among is DNA, and we all know that DNA, which is very small to see, and we have to see using microscope, and DNA stands for deoxyribonucleic acid, and which is found in all living things, which is very common to trees and human being or animal. And we all know that every living thing has a cell, and each inside the cell we have nucleus, and inside the nucleus we have chromosomes, and this chromosomes is made up of this long strands of tightly coiled DNA. And this DNA, which looks like twisted ladder, it looks like this, and this is the chemical bond between the DNA. That is, this DNA is made up of four bases, that is AGCT, and A stands for adenine, and G stands for guanine, and C stands for cytosine, and T stands for thymine. And always, and we say this is a double stranded DNA because A always, that is adenine, always bound to thymine, and guanine always bound to cytosine. And in other way we can say that A's complement is T and G's complement is C. Same way, T's complement is A and C's complement is G. So using this DNA computation can be carried out, and which is nothing but it is a computation which uses DNA strand, biochemistry and molecular biology instead of traditional silicon based computer technology. So the reason behind for choosing this material is its important characteristics we have. The first thing is it is a dense information storage. That is, in the right hand side we have CD, where you can have a 1 gram of DNA. So if a CD can hold around 800 MB of data, this 1 gram of DNA can hold about 1 into 10 power 14 MB of data. So that's the enormous storage can be carried out with a small amount of DNA. And the second thing is, the DNA, each base, it will take about 0.35 nm for storing the data, for storing each base. That is, 1 gram can hold so much of bits. That's the dense information storage is possible. And second important characteristics is the parallelism. That is, a test tube of DNA can have like trillions of strands, and all the trillions of strands can be operated simultaneously. So this much amount of molecules can be operated parallelly. So it has an enormous parallelism can be carried out. And energy efficiency, Adelman is the father of DNA computer, and he has given 2 into 10 power 19 operation per joule can be carried out. So it has a very high density of storage and higher parallelism, and massive parallelism can be carried out, and energy efficiency is there. And these are the advantages of DNA computer. Inherent parallelism, by nature DNA has parallelism, and the data density is huge, and which is a very cheap resource, and energy efficiency is there, and above all that it is a non-toxic material. And these are the main reasons people are trying to do computation using DNA.